All right, we've got one more to do, and let's do some black. And this is called the Ortho Center. Isn't that crazy? I don't know where they got that. A lot of centers, right? Even centroid had kind of the word center in it, didn't it? All right. So let's just do it. I'm actually going to use 2 different triangles in this situation. All right, the Orthocenter. Actually, you know what? I shouldn't have. I kind of broke my streak on this because usually, what did I do first? I talked about the perpendicular bisector, then and then I transfer that to the triangle. Then I talked about angle bisector, and then I said how it works in the triangle. Then I talked about median. I said how it works in the triangle. So technically, you didn't hear me say that, did you? All right. So here's another word. Right. That's what I thought. Here's another word. It's called altitude. Altitude. All right, let's talk about what the altitude is. And I think we might have even talked about altitude earlier in the year. If I talk about the altitude, I like to use this example all the time. Let's say this is the ground, all right, and then you got a nice, cool airplane. I'll embarrass myself with my drawing here. That's an airplane right there. See? That's the windows. See, that's the guy inside there. Wow, that's horrible. Okay, anyway, so that's an airplane. He's flying this way. Now watch. Actually, let's move the ground down. He's a little higher now. Okay, so if the pilot's up there and he said, you know, you've flown commercial, haven't you? Anybody flown commercial airlines before? Yeah, and they say, listen to me. They go up there and they say, there's your captain speaking. Thank you for flying whatever, Delta Airlines or whatever they say. And then they say, what do they usually tell you? Oh, the weather is going to be this when we get there. It's going to take this long. And they say, we'll be flying at an altitude of whatever, 20,000, 30,000 feet. Okay? What are they talking about when they're talking about the altitude? How high? Is it from here to where you're going to land? Is it from here to where you started? Okay, it's perpendicular, right. Okay. It's perpendicular. So when we talk about the altitude, listen to me now. When we talk about, let's not worry about it. Okay, we've already had our laugh. Now we're talking math. When we talk about the altitude, we talk about the perpendicular distance. You with me? And we've talked about that before. Remember we said the distance from a point to a line is the perpendicular distance? Well, that's what the altitude is. So it's just another word that describes something that we've talked about already before. So what we're going to do is we're going to take a triangle and we're going to draw the altitudes to the triangle. So I'm going to start at a vertex. I start at all 3 vertices. And then I draw a perpendicular down. That right there is an altitude. It's not a perpendicular bisector. Remember perpendicular bisector? It was perpendicular, but what did we do? We found the midpoint of this side and we just popped a perpendicular at the midpoint. Is this the same thing as a perpendicular bisector? No, it's not. Where does it start? It starts at the vertex and it drops down perpendicular to the opposite side. You okay with that? All right, let's do all 3 of them. So watch. Let's take this one. Where's perpendicular? Does that look perpendicular? Nah, about right in there somewhere would be my guess. Again, we just have to eyeball it. That's pretty close to perpendicular. It's pretty close. All right, and let's go perpendicular here. Now, guess what they do? If I go perpendicular, they just happen to do what? That's perpendicular, isn't it? Doesn't that look like a right angle right there? Yeah, that's okay. I said we're eyeballing it, didn't I? So give me a little slack. Give me a little slack, okay? Yes. All right. That point right there, guess what that point's called? Orthocenter. Wow, how'd you know that? Because I never said that word before, did I? Okay. Remember we said we weren't supposed to remember them? All right, so anyway, so that's an orthocenter. So this point right here is an orthocenter. Now, remember how the other 3s had something specific about it? The circumcenter, I'll say it again. It's like the 3rd time I've said this today. The circumcenter is equidistant from the 3 vertices. Remember? The incenter is equidistant from the what? The 3 sides of the triangle. Okay, and we learned something about the centroid. What did we learn about the centroid? That the centroid from the vertex to the centroid is 2/3, and from the centroid to the midpoint is 1/3, right? So we learned something about, right? It has some kind of relationship. Well, guess what? Orthocenter, nothing, right? It's not a certain distance away from a vertex. It's not a certain distance away from a side. It doesn't have any kind of relationship between this segment and this segment. There's real no relationship. The only relationship that these three lines have would be what? That they are, we've said this word again before. Say it. Well, they're perpendicular to the sides, but all three together, what do? They have a common bond. What do they all do? Yeah, they all intersect, which means they're what kind of lines? Concurrent lines. Now, all four of the things that we've discussed are concurrent lines. This one right here doesn't really have anything special about this point. All right? That point is not special. All right? So, except the fact that they all three intersect each other. That's it. All right? Just because they want you to. All right? So, there we go. That's the orthocenter. That's where it is. All right? Now, look, that's to an acute triangle. It also works with an obtuse triangle, but guess what? The orthocenter doesn't lie inside the triangle. Let's do this really quick because I'm quickly running out of class time here. Watch this. If I do the, I start here and I go perpendicular, which looks about like that. Okay? Let's start here and go perpendicular. Wait a minute. That's not perpendicular. It gets worse and worse if I go this way, so what do I got to do? I'm going to have to do what? That's right. I'm going to have to go outside the triangle, aren't I? All right. So if I do this, watch. I might have to extend. I'll tell you what. I'll just do it like this. I got to extend this triangle out like this. Or that side out like that. Follow me? So watch. Why is it retarded? And we do that all the time. Okay. Hang on just a second. So look. We would extend it here, wouldn't we? You follow me on that? Okay, and let's do that. Just wait. It's perpendicular because it's perpendicular to that extended side. Let's do one more. What if I go from here? Can I get perpendicular here? No. So what am I going to have to do? I'm going to have to extend this side out like this, right, until I can drop this perpendicular like that. Now, if you look at it, they never intersect, but watch this. If I keep extending them, look what it does. Okay? Well, I was off a little bit. We'll say it's here. You get the idea. If I did it accurately, they would all intersect. But where do they intersect? Outside the circle. Don't leave. I got to give you some problems to do. Okay. Let's see. Numbers 5 to 24. So it's section 5-2, 5 to 24. Page 338, 339. Okay? There it is.